Hello there, this is Chris, and here we're taking a look at a pulley system. So as part of our video series on pulleys, we're now going to look at what happens when you have more than one pulley. So this situation is going to look a little bit more complicated than when you have just one individual pulley, but in terms of the principles that we're going to apply, it's going to be very similar. So let's label these as, I'll call this M1 and M2 for the box and the bucket. And let's start labeling a couple of our values. So here we have a tension that's pulling up on the bucket. And then for the box, this is what's important to note. So we can see in our pulley system now that we have these two pulleys, the box is going to have tension pulling up here and tension pulling up here as well. And what's important to note, again, just like we talked about in our previous videos, that these tensions are all going to be the same. So there's no such thing as a rope or a string that has a particular amount of tension on one end where it's not the same on the other end. This is going to derive from Newton's third law. But this tension in each of these places is going to be the same. And the reason that that's important is because mathematically that is going to have an impact on the values that we have for the movement of each object as to what's being either added or subtracted depending on the direction of motion of this pulley system. So just keep in mind that you've got two of these tensions pulling up on the box versus only one tension pulling up on the bucket. Okay, now let's talk about a few of our other forces, and some of these are going to be the same as what we've seen previously. So here, for mass 1, you still have the same force of gravity, m1g, and for mass 2, m2g. So those forces due to gravity are going to be the same. And again, for right now, for this intro, we're going to assume that this is going to be a static system for the moment. So if everything is still, then we know that these forces are going to cancel out, because the sum of the forces for your net force, right, F net would be ma, just like Newton's second law always, whenever we see it. And if your acceleration of the system is 0, then your net forces are going to be 0, which means all the individual forces are going to cancel out. So for this to be the case, we know that for mass 2 over here, our tension would be equal to m2g. And then for mass 1, that's important, because remember, we have these two tensions. So what's pulling up on mass 1 is going to be 2 times t, and that would cancel out with m1g for this. So again, for right now, we're just looking at this as a static system, and we're trying to identify which forces are going to be equal in magnitude, although opposite in direction. And that's what we see here with these two tensions and the force due to gravity on mass 1. And that's what we see here with this single tension and the force due to gravity on mass 2. So that's our baseline for this two pulley system. And here, again, the most important takeaway is this. Make sure that you include all of the appropriate tensions that are applying a particular force on an object, because that's going to impact your free body diagram, and that's going to impact your force calculations. Now stay tuned, and in our next video we're going to take a look at this same scenario, but we're going to look at a scenario where we don't have a cancellation of forces, but we're going to have an actual net force. So we're going to talk about what's happening if maybe, let's say in a word problem, we add some water to the bucket and then it starts pulling down on the system. Or maybe we remove some water from the bucket, and so then the box starts pulling down on the pulley system on the other side. So stay tuned, and we'll dive into that next.